The next part of 4.2 that we want to talk about is the composite functions. And for the composite functions, it's really like the turducken of math. So I've given you a picture here of a turducken. If you don't know what that is a chicken and a duck stuffed into a turkey. Or sometimes people like to say it's the duck stuffed into the chicken and then stuffed into a turkey. So it's one thing put into another thing, put into another thing. And that's really what fog and golf are that we're going to talk about here, which are the composite functions of math. Fog is f of g of x, which means we take g of x and we put it into f of x. And golf is g of f of x, which means we take f of x and we put it into g of x. So again, much like the turducken, it's putting one thing into the other thing. You know, if you've had a turducken, why don't you go ahead and make a comment on the video that you had. I'm always interested to hear and talk to those people who have had a turducken, since I've never had one. I've usually only seen it on the Thanksgiving Day football game done, when I see my Lions get to play. The one time a year they're on national TV. And it seems like the players who eat the turducken are fairly excited about eating their turducken. So, all right, so now we're going to go ahead and look at example 6 on page 268 and use our fog and golf and actually extend it slightly further. So let's go ahead and get these images out of here and get a fresh palette to work from. Now that we have a foundation for the composite functions, let's go ahead and jump in to do example 6 on page 268. So they give us f of x is equal to 2x minus 5, g of x is equal to 6 minus x squared, and h of x is equal to 1 over x. And then the first thing they ask us is something we haven't seen before. They ask us to do the Hoff of x. And I see Hoff and I think of David Hasselhoff. So I had to bring his picture in here just so we could see that and all be on the same mental page as me. All right, let's go ahead and get rid of Mr. David Hasselhoff here. And continue to do our problem. All right, so they give us h of f of x, which again for us is going to mean h of f of x. So what that really means is we're going to take the f of x function, as in 2x minus 5, and we're going to stick that into the h of x function everywhere we see x. So if we properly set this up, this is going to read h of 2x minus 5, because f of x is 2x minus 5. And then with that, we go into the h of x equation, which is 1 over x, and we say 1 over, it's no longer x anymore, that x is being replaced with 2x minus 5. And again, if we can simplify this in any way, shape, or form we'd want to, we cannot, and so we'd call this one good. Moving on to part B, so they do ask us the classic fog question, so f of g of x. Again, we read that as f of g of x, meaning that we're going to take the g of x equation, as in 6 minus x squared, and put that into the x in the f of x equation. So we only have one x here. It's 2 times x, except that x is going to be replaced with 6 minus x squared, as in 2 times 6 minus x squared, and then there is a minus 5 after that in the f of x equation. Now, it's not good enough to leave it here. Certainly, we have to distribute our 2. 2 times 6 is 12. 2 times minus x squared is minus 2x squared. And, of course, we still have this minus 5. And we can consolidate the 12 and the minus 5 for a grand total of plus 7. And so we're going to have our final answer being minus 2x squared plus 7. And there we go. We worked in my favorite number on that problem as well. Our part C, this is the classic golf. So g of f of x. Again, reads as g of f of x. Which means we're going to take the f of x equation now, this 2x minus 5, and we're going to put that into the g of x equation for x. Now this x is being squared, and so our 2x minus 5 is going to have to be squared as well. But let's get it set up first. So that's going to mean g of 2x minus 5, which in our case means 6 minus x squared, except x has now become 2x minus 5. And so for us to properly complete this problem, we're going to have to take 2x minus 5 and square it. So let's go ahead and do that as a sidebar over here. For those of you who can't remember how to do the FOIL, let's just do it in real time. So we've got 2x times 2x. That's going to be 4x squared. We've got 2x times minus 5. That's minus 10x. Then you've got 2x times minus 5, another minus 10x. And finally, minus 5 times minus 5, which is positive 25. The two 10s do add together, or in our case, subtract together, to give us minus 20x and plus 25. So this problem over here has become 6 minus 4x squared minus 20x plus 25. We want to distribute our negative sign, so it becomes 6 minus 4x squared plus 20x minus 25. And then we can add the 6 and the 25 together for us to get negative 19, and that's where this problem is going to end. So we're going to see this as minus 4x squared plus 20x minus 19. And that would be the Goff answer of this particular problem. The final part of example 6 that we need to talk about is the last piece of instructions that says give the domain of each new function formed. So what we want to look at is each part of the end of a, b, and c, and then ask ourselves, is there any restrictions on the x? In example A, there is a restriction because we have a denominator. We have 2x minus 5. And what we need to know is what x value would cause 2x minus 5 to equal 0. So I'm going to say 2x minus 5 equals 0, which tells me 2x equals 5, which tells me x is 5 halves. So 5 halves is one of the no-no values that we can't have. In other words, our domain would be everything but 5 halves. On part B, I don't see a restriction of what x can't be as far as the domain goes, and the same goes for part C. I don't see any restrictions for x. So really the restriction only comes in the form of a fraction most times, but that's not exclusive.